Welcome to our new video. In this video, we are going to discuss about decision tree. In this video, we are going to elaborate on the background function of a decision tree, discuss the general structure of a decision tree, illustrate a decision tree with the help of raw data, learn how to select the best attribute for the root node and for subnodes, discuss the challenges associated with decision tree. The decision tree algorithm models relationships and independencies between the predictive outputs and the input features. For example, can features like gender, income, age and located predict if an individual will purchase the product? As the name suggests, the decision tree algorithm is a tree structure classifier preferably used to solve classification problem. When a decision tree classifies values into separate categories, it is called the classification tree. When it predicts a numerical value, it is known as the regression tree. Actually, in machine learning, decision trees are categorized under supervised learning technique, which are defined by the users of labeled data sets. The labeled data where predict the values is known for example, who is likely to purchase the house. Supervised learning does so by creating a training models that pull out the decision rules from the prior training data and then use it to predict the class or value of the target variable. It consists of nodes divided into three types: a decision node, an internal node and a leaf node. A decision node or a root node is at the very top of the decision tree. It represents the question and it has two or more branches, also called internal nodes. These branches represent the possible solutions to the problem. Lately, the leaf node represents the actual output or class label. There is no further classification of a leaf node. Now, we will discuss a real-life example of a decision tree. Consider an individual preference while buying a house if the area of a house is above 1000 square feet. You will have the further constraints and parameters to decide from, such as a number of rooms and the nearby area. If any of these conditions are not met, the house won't be bought. However, the individuals may consider the purchasing the house if it is above 1000 square feet or has more rooms than 5 with amenities nearby, but it is not always as small as it seems to be in this example. It often gets complicated to select the best attributes among them to get an associated answer for the root nodes and the subnodes. We use attribute selection technique to solve that. The attribute selection method techniques calculate value for every attribute. The values are sorted and attributes are placed in the tree by following the order. In brief, the attribute with the high value is placed at the root. A few attribute selection techniques you must know about in machine learning are entropy, information gain, Gini index. Entropy, which is a measure of the randomness of the information being processed. The randomness refers to the irrational and misinformed trends that contribute to the misrepresentation of the underlying information. Next is information gain. It shows the difference between the entropy of the root node, the weighted average entropy of internal and the leaf node. Then we have the Gini index. It measures the purity and the impurity used while creating a decision tree. Note that an attribute with a low Gini index is preferred given a high Gini index. Further, comprehending the design of a decision tree. Identify the objective of your decision tree, listing out all possible choices or actions, identifying the criteria for each decision, evaluating your decision tree diagram. The decision tree empowers you to solve decision related problem. It helps to identify all the likely outcome for a problem. One major problem with a decision tree is their high variance. A minor change in the training dataset can give an entirely different tree. After when choosing between completely attribute, decision trees are preferred due to the simple and explained model with a relatively lower accurate that is tolerable. Moreover, these trees containing lots of nodes which can sometimes make it complex. While drafting a decision tree, you may have an overfitting issue that can be solved by advanced algorithms such as the random forest. For more class label, the computation complexity of the tree may increase. That's all about it. Thank you for watching.